Hey y'all, let's have some fun with functions. What do you say? Let's start with linear. Y equals ax plus b? I thought it was mx plus b. Doesn't matter, just a variable that stands for a constant or for a number. Let's say we move the a or the m, which is the slope, around. You should know that it's going to change the slope and it's going to change. Yeah, there you go. Got that one. And then the b, well, of course, if you change the b value, it's going to raise or lower that line on the y-axis. Okay, so this is stuff that we know. Let's move on. And this is where you want to start writing this down. So write down y equals mx plus b, where we know m changes the slope and b changes vertically the y-intercept where it's positioned on the y-intercept or on the y-axis. Give an equation for each type of linear function. Okay. So just dance, dance, dance. So just dance, dance, dance. So just dance, dance, dance. So keep dancing. So that's easy. That's review. Let's go on to the quadratic. And notice how I have the quadratic labeled here. I have y equals a times the quantity x plus b squared, so therefore it's quadratic, plus c. I want you to know exactly what happens when you manipulate every number in this equation. Okay, ignoring y and x, which is your x is your input and y is your output. But if you start with the a value, that is going to expand and contract the quadratic. So it's going to make it increase, get tighter, decrease, get wider, and then once it goes negative, it's going to flip. Okay, so this is actually kind of hard to see as if I move down here. Watch it flip over like that. So anytime the a value is negative, in this case it's negative, let's just make it -1, okay, negative 1.2. That flips it over into the arch. But if it's positive, then it's going to be more like the smiley face. If you change the b value, what you're doing there is just sliding the quadratic left and right. So if you want left, right movement out of your quadratic, change the b value. Okay, you can. It's kind of strange though when you make it a positive, it actually goes left. Notice here the b value is positive 9.5. When you make it a negative, it goes right. So that's counterintuitive to what you think was going to happen. And then the c, that just raises or lowers your quadratic up and down. Okay. Oh, where'd it go? I don't like that there's a little bit of a delay here, so I'm trying to like slowly move it. Man, that's really lagging behind what I want. But yeah, the c value is vertical movement up and down. Now, based on what we just talked about in the Desmos graphing calculator, give an equation of each type. Well, if it's going to have a maximum, that means it has to have a highest point. So if it's going to have a highest point, you have to have a negative a value. That's when it flips. So any variation of a negative a value here, let's say like -2, and then x, it doesn't matter if you put anything added on to the x or not, or even like change it vertically up and down. As long as there's a negative there, it'll be flipped upside down. Has a minimum, well, that means it's smiling at you like this, because that means it has a lowest point or a minimum right there. So you just have to have a positive a value. So let's just flip that to a 2. You could have x plus whatever you want. You could have something at the end. Doesn't matter as long as that number right there is positive. Does not touch the x-axis. Well, okay, that means we probably want to move it up or down on the y-axis so it's not touching the x. So if we start with something, first of all, that has a positive a value, and you could shift it left or right, that really wouldn't matter. But from this moment here, you know it's smiling like this. And if you just raise it up 1 unit, so if you just go +1, that will now be above the x-axis and will not be touching it. Okay. Same would be true if you flipped it down like a -2 and then moved it down 1 unit, would not touch. Therefore, has no solutions if you were to solve it. Now, I want you to notice the consistency, the commonality, all the stuff that's the same about these functions and how you're changing the a, b, and c in each one. So let's go to the exponential. It has an a, b, and a c. A is in front of the base of 2, raised to the x power. If x is the exponent, it's exponential. So the x is up there in the exponent spot, plus b, and then a plus c at the end. Okay. So the same 3 things are going to happen with the exponential. If you change the a value, that's going to change the rate of increase, or like exponential growth. Once it goes negative, it flips. So then it would be going exponentially decreasing, okay, and going down. flip it back up. If you change the b, you're going to get left-right movement out of your exponential. See that? Goes to the left, goes to the right. Again, counterintuitive. Negative is to the right and positive is to the left. And then the c, again, is vertical movement, up and down the y-axis. Okay. All right, exponentials, always increasing.
It's not unusual to be loved by anyone. It's not unusual to have fun.
Well, for it to be increasing, the a value has to be positive. So y equals some number in front of the base, let's say 3 times 2 to the x power. You should just leave it like that. Let's keep it simple. But you could add or subtract onto the x. You could throw a c value in there. That a is positive, it's going to be increasing. For it to be decreasing, a has to be negative. So y equals negative 2 times 5 to the x power. Change the base. As long as that a value is negative, boom. Touches the x-axis at 0, 0. How do we do that? Let's start with like the most basic one that you can think of. That's the most basic exponential I can even think of. Okay, it has a 1 in front for the a value, so it's positive. Okay, because it's not there. And if you input 0 in for x, right there, you want the output to be 0. So if you put 0 in for x, what's anything to the 0 power? Right, that's 1. Okay, so if this is 1, that's not the desired output we're looking for. We're looking for that to be 0. So you'd actually have to subtract 1 off of this function to get this to be y equals 1 minus 1, which y is 0, which is the desired output. So you're going to have to minus 1 from there. Okay? So you have to just kind of reason through it. Let's take a look at absolute value. Same 3 letters, same 3 movements. The a, where is my absolute value? You can come back here. You know what? If I want to like shift it back, the c's at 2.4. Hey, buddy, there you are. See, it's a V shape. The a is going to expand and contract the v. Notice it's expanding, and once it goes negative, it flips. The b is going to move it left and right. Again, positive moves it to the left, and negative moves it to the right. Okay. And then the c, you already see me shift it that way. It's going to go up and down vertically. Absolute value. If it has a maximum, it has a highest point. That means the a value is now negative, so it flips upside down. So just stick a negative in front of your absolute value, and then you can run with it from there. Okay, add or subtract anything you want as long as the negative is here. For it to have a minimum, it has to have a lowest point, which just means the a value is positive. You can put a 1 in front of there, you can put a 2, just as long as that number is positive. Okay. Oh, has a maximum value, maximum, okay, so it's got to be this direction, upside down, at 0, 7. So you're looking to move this thing 7 units up in the y direction. That would be this number over here, okay? So most basic one I can think of, y equals the absolute value of x. You basically just have a v at this point, okay? But it's going up. Stick a negative in front, and now you've flipped it down, and then move it up 7 units. All you have to do is add on to the outside of the absolute. So as long as you have a negative here and a plus 7 at the end, it'll be as a maximum, and it's up there at 0, 7 because you raised it up vertically 7 units. All right, the last one I want to look at real quick is the radical. Same 3 letters, A, B, and C. If you start with the a value, again, it's going to increase the rate at which it is shooting up there with that radical. Or if you go negative, then it flips down. Okay. So it's kind of like rate of increase and decrease. And then the b value, let's see, what the b value has always shifted it left and right. So that better happen here. Okay, let's take a look at it. Yep, left and right. Again, counterintuitive. Opposite of what you think is going to happen. The c is what is expected. As you go positive, more positive, it's going to go up. And as you go negative, it's going to drop down. Okay, so those are the 3 radical. All right, give me a radical function that begins at -2, 0. Which
Everybody.
plug in -2 for x, the output has to be 0. So let's start with, what could you do to the x to make the output 0 when you plug in -2? Oh yeah, +2. So if you add 2 onto -2 when you plug it in, you would get an output of 0, and you'd be in business. Cool. Give me a function that does not touch the x-axis that is radical. Well, this would be kind of irrelevant. Let's say it's positive. So we'll just start with y equals radical x. And then I want to shift it above the x-axis vertically. That would be this value again over here. So just add on to your radical, make sure it's outside the radical. If it's inside the radical, see how that would be left-right movement, and you just be sliding along the x-axis. Let's go +1. That would shift it up 1, no longer touching the x-axis. Does not touch the y-axis. Okay, let's go back to our original, like that. And then we don't want it to touch the y, so we just want to shift it probably to the right if it's going to be a positive here, because otherwise it's going back down or to the left. Yeah, so let's just move it over 1. Now this is counterintuitive. That's what I talked about when we were going over Desmos. If you put +1, that actually goes to the left. So if you go -1, it actually shifts it to the right. And here's why. Now you have shifted the available numbers that you're allowed to have in the domain. Okay, you can't plug in 0 into this function, because what happens when you plug in 0? You get -1, and the square root of -1 is imaginary. It does not exist. So now +1 is the first number you're allowed to plug in, because 1 minus 1 is 0. And therefore, this thing now begins at 1 on the x-axis and goes from there, so it does not touch the y. Okay, fascinating. That's the end of the lesson for right now. Linear piecewise functions are coming up. You know that's something we're going to do. But for this guy, I just want to make sure you have fun with your functions. You know how to manipulate them and move them around. And to do that, you got to know how to do this.